So our final unit in pre-calc is all about limit, and it's actually going on to calculus. So pre-calc honors and pre-calc are doing the same unit. So if you need or have a friend in honors, you can discuss with them because you have the same notes and same homework. So first we got to decide what a limit is. So what we're going to do is we're going to look at these four circles and we're going to discover that if we increase the number of sides of the polygon, what can you say about each polygon with respect to the circle? So if I'm looking at the first one, the triangle, I see it doesn't really represent a circle. If I move to the square, I see, okay, well, it's starting to maybe resemble a circle. If I move to the hexagon, I can see that it's getting closer and closer to being a circle, but isn't a circle. If I get to the next one, I see it still is closer and closer, but there's still these little gaps here that make it not a circle. So basically, if we refer to the polygon as an n-gon, where n is the number of sides, we can make some mathematical statements about it. As we can see, as n gets larger, the n-gon gets closer and closer being a circle. So since we went to triangle to a hexagon, we saw that it got closer and closer to becoming an actual circle. So as n gets larger, it becomes closer and closer to being a circle. Now that's pretty basic. So let's take this up a notch and discuss it in mathematical terms. What we say is, instead of saying the n gets larger, the n-gon gets larger, we say as n goes to infinity, meaning as the number in sides increase all the way up to infinity, then it says is a circle. And that's what our limit is. So our limit is basically how close something can get to an actual object, or on a graph a number, but it will never become that number. So a limit just means a graph that approaches a number but will never be that number. So let's apply this to a graph. It says, suppose you and your friend are walking around the graph with the function f of x equals x squared minus 4 over x minus 2. The graph below shows that you and your friend are walking in opposite directions towards each other. Because 2 is not the domain, so remember 2 is not in the domain because this is a vertical asymptote, meaning that x equals 2 won't work in this graph because it's undefined. So there's going to be a hole in your graph at x equals 2. If you and your friend reach 2, so x equals 2, you would fall through the graph. We know that there is a problem at x equals 2, but what would happen along the graph as you got very, very close to 2? What function value would you approach? That would be what we call a limit. So what we're approaching, but if we arrive there, we're going to fall through. We cannot use the function itself to find the value. However, we can use a table very close to 2 from both sides to estimate where that function value would be, or the limit. So going on to the next page, here's our function. As x approaches 2 from the left, I notice it's going from 3.99, and then it just keeps adding 9s, and then as x approaches from the right, it starts with 4.0001. So from either way, we're getting closer and closer to the value of 4. So as we see that x gets closer to 2, the values of the function get closer to 4. How we would write that is the limit as x goes to 2 of my function up above would be 4. So this is always a y value. So we write down there, you can write f of x, or you can actually put the fraction in, but it reads as the limit as x approaches 2 of x squared minus 4 over x minus 2 equals 4. So what we're going to do is we're going to practice using a table to find those limits. So I see it says the limit as x approaches 4 of 3x squared. So I'm going to hop on my calculator and I'm going to type in 3x squared. I'm going to hit graph. and it says as x approaches 4. So I'm actually going to look at the table. Now as I approach 4, I see that 3 is 27 and 5 is 75. However, I can't use that exact value of 4. I have to see how close it is. So that's a pretty big jump from 27 to 75. So what we're going to do is we're going to set up our table so it's different. So we're seeing as x approaches 4. So I'm going to start our table at 4. Next, I want to see how close it gets. So I'm going to change this, and we're going to go up by 0.01. So now when I look at it, I see that from the left side, as it goes closer and closer to 4, the numbers are getting closer and closer to 48. As I'm coming up the right side, I see that the numbers are going from 49 to 48 and getting closer and closer to 48. Therefore, you can recreate this table on your iPad. So I'm just going to draw it out. This is my x value, this is my y. We saw it was 3.7. Or 3.97, 3.98, and so on. And these were the outputs. So as we got closer and closer to 4, our y value got closer and closer to 48. So that would be our limit. So to write that then, we would say the limit as x approaches 4 of 3x squared equals 48. So let's try another one. Sine x over x. So if I did sine x divided by x and graphed it, we're looking at where x is approaching 0. So I'm going to start at 0 on my table. And then as I see, as it approaches from the left side, even though this is an error, as it approaches to the left side, it gets closer and closer to 1. As it approaches from the right side, it gets closer and closer to 1. Therefore, my limit as x approaches 0 of sine x squared, or sine x over x, is just 1. And again, I would want you to recreate that table. Last thing today is using graphs to find limits. So there's a couple different things. Limits can also be determined from the graph. In the following graphs, the limit of x approaching a, f of x equals L, is illustrated. These are 3 situations that can occur. So the limit is equal to the function value. So that would be, if I plug in like f of 4, my limit would be the same thing. The function value we are approaching doesn't exist, meaning there would be a hole in your graph, or the limit and the function value are different, meaning that it would be a point discontinuity. So what we're going to do is we're going to look at the graph and figure out all our limits. So starting with that first one, it says limit of x approaches 4 of f of x. So when it says the limit, we want to follow the actual line. So we're not looking at x equals 4, we're looking what happens as that line approaches x equals 4. So if I'm looking at 4, it's this one here. Again, we're not looking at the actual value, we're looking at the limit. So we're going to see what this line is doing as it approaches 4 from both sides. So if I'm looking at the left hand side, I see it's approaching 7. If I'm looking at the right hand side, I see it's approaching 7. Therefore, my limit as x approaches 4 is 7. Now that's different from number 2, which is f of 4. So 4 means the actual value, which means I'm looking for a closed circle. So on x equals 4, I notice my y value is 2. Therefore, f of 4 equals 2. So when it says limit, you follow the line. When it says f of a number, that's when you look for a closed circle. So let's try this again. It says limit of x as it approaches -2 of f of x. So again, I'm looking at -2, and I'm following the line. So as I'm getting closer and closer to -2, I notice that my y value is 5. Therefore, my limit as x approaches negative 2 is 5. However, that's different than f of negative 2. So if I'm looking at the actual value on negative 2, I have to look for a closed circle, and that would be 3. So f of negative 2 is 3. So again, you might be asked to do a piecewise function. So let's look at this one. We're going to graph and then use the limit to find x approaches 3. So looking at this one, it says 2x minus 4 if x doesn't equal 3. So it's basically negative infinity to infinity without x equaling 3. So to plot a line, remember this is your b or y-intercept, and then 2 is your m value or your slope. So I'm going to start at 4. I'm going to go up 2 over 1. Up 2 over 1. However, when I get to the value x equals 3, I need an open circle on it because it's not included. And then you can continue graphing. And then I would just draw that line. And it would look something like that. The second one says negative 5 if x equals 3. So that would be like the point 3, negative 5. And that would have a closed circle on it. So 3, negative 5 is here. There's a point discontinuity here because I see it's an open circle on a line, and 1 point is missing. So now what we're going to do is we're going to find the limit as x approaches 3 of this function. So since we're talking about the limit, we have to look at what this line is doing. So if I'm getting closer and closer to x equals 3, I notice my y value is getting closer and closer to 2 in both directions. Therefore, the limit as x approaches 3 is 2. Remember, that's different than f of 3, which if I'm looking, f of 3 would be where this closed circle is, which is negative 5. So today you're going to do 11.1 homework on the homework packet. It's going over tables and then using graphs.